Hi guys, in this video we're going to be looking at sending our telemetry from our Taranis to other devices via Bluetooth. This is something that I've been trying to do for a little bit and had lots of problems with it. And thanks to some of the guys in the Fixed-Wing RC Rebels groups, I managed to get it sorted out last night. And actually once you get the basics sorted and the teething problems fixed, it's actually quite simple. And one of the guys in the group wanted me to make a video to show how I did it and how to go about doing it from scratch. So this is what we're going to do today. So what you can see in front of you is my finished Bluetooth module. This one is set up to communicate with like Android devices or anything like that. So it will pass the telemetry onto programs like the guy CrazyDude, who I'll put a link to in the description. He's the guy that came up with the Android program, and it will show you all your GPS and stuff, but we'll look at that later. The first thing we'll do is actually make the modules. So what I've done with this one is this is a standard Bluetooth module, which I'll get a link to in the description. I have this cable here, which will plug into the back of an R9 unit, which uses the standard sort of SmartPort wiring layout. There we go. So you can see the middle pin is power and the outer pins are ground and signal. So that's like a normal servo on anything else. But what I also have is this one here set up for a JR bay. So if the R9 module's not in it, I can stick this in the JR bay, which as you can see is wired differently. The ground is in the middle, the positives at the top, and the signals at the bottom. So I can take the R9 unit out, plug that into the JR bay, and then you just have to enable the external module in the Taranis, and you'll be able to get your telemetry from other stuff like X4Rs and stuff like that. Right, so let's talk about how I made this. So I start with this is the Bluetooth module that I'm using. They call them HC05s. But this one seems to be a slight variation of the HC05, which is why I was having the issues. So if you look at the back of this one, you can see it is a ZS040, which is a derivative of an HC05. So they sell them as HC05s. But the way you program it is slightly different. And that was why I was having lots of issues being able to communicate. So as far as devices go, it's very simple, really. If you've wired up a GPS or anything like that, you'll probably already see what you need to do. We've got a UART on here. So we've got our receiving pin, our transmitting pin, and then we have a ground voltage in, which is 3.6 to 6 volts. And then we don't care about this state pin. By the looks of it, that's transmitting what state the module's in for connected to other things, so it can tell the other things whether it's in like a programming mode or something, I guess. What we want here is this EN pin, which in some tutorials they call it a key pin as well, but key and EN is the same pin. So we need the bottom 5 pins basically. But what we also need is a way to communicate with that. So I'm using this little dongle here, which I bought off of Banggood, and this is basically a USB to TTL converter, and all that does is take your USB and sticks a UART on it. So let's try and focus again. There you go. You can see we've got the 5 volts out at the bottom, ground out, then we've got the receive, transmit, and a 3.3 volt pin at the top, which is really handy because we use that to connect to the key pin. Right, so the next stage is wiring it all up. So for that, I just have a really simple extension cable, which just got basically little JST servo type pin individuals on the end. And all I'm going to do is I'm going to just stick this onto the TTL, and then we'll just wire it from there. So I'll just get all these on. Don't care what the colours are. So they're on there. So we have black is our 5 volt, so that will go to VCC. We have white is our ground, so that will go to ground. We have grey is our RX, so that will go to TX. It's quite nice actually, because TX and RX are reversed on this module to that module, so it's pretty simple to wire up. Then the purple is TX, so that goes to RX. Again, if you don't know about UARTs and all that sort of stuff, I've made a video yesterday actually about UARTs, so I'll put the link up in probably a corner somewhere, and you can check that out and find out what UARTs mean and how to wire them up. But yeah, the last pin is the 3.3 volts, and we'll stick that on the EN at the bottom, which may say key on yours. So that is the wiring done. That's the extent of it. It's really difficult, I know. Right, so the next thing we'll do is I'm just going to grab a USB extension cable, and then what we need to do is when we plug this in to power it up, we need to hold this button as well. This was where I was going wrong. A lot of tutorials say you either hold the button down or you use this cable, but with this particular unit you need to do both. So you hold the button down, and then I'll just plug it in, and then once it starts bleeping, or once the LED starts flashing slowly, you can let go of the button, and that's it. It's ready to accept our commands. So what we'll do now is we'll head over to the desktop and we'll take it from there. So what we're going to use is a package called Termite, and again I'll put the link in the description below, but this is a really simple package to use for doing this. So the first thing we need to do is make some settings changes. We need to first check the communications port. To do that, if you right click on your Windows button and choose the device manager, you'll get a list which will pop up on the screen in a sec. There we go. And you go down to ports, and then you can see UART bridge is COM5. So we know that our Bluetooth module is on COM5. So what we do is close that, choose COM5, and that's the module. The next thing we need to do is to change the transmitted text type. I found on this module the append, CR and LF works, but you may find yours is different. So if it doesn't work, just try all of those 4 options and see which one comes out the best. So we close the options and it automatically connects, and we can type in uppercase the command AT, and what we should get back is OK. Now that OK was the thing I was struggling about for absolutely ages. No matter what I did, until I powered it on with holding the button down, it would just not work. So what we have now in the notepad on the side, again, I'll put these in the description, are the different settings we need for setting up the modules for a different purpose. So the top one here is if you want to connect to an Android device. So this would be to use CrazyDude's Android software, or like to set it up as a ground station, that kind of thing. So basically the commands again are slightly different on different modules. These commands all work on this module, but for example, sometimes the one for password is actually pin, sometimes UART is board. That they vary on different modules. So again, this is purely for this type of module. And all you need to do is copy these commands in and paste them in. Or if you want to type them, you can. This user interface is really nice because you can just type them in and then click the button. Usually if you type them in using another terminal thing, you have to input them within a second, and there's all sorts of stuff like that. The other thing you can do is check what's already on the device by using the command and then a question mark. And that will print out on screen what the device is already set to, so you can see what it's already set up as. So what we'll do is we'll copy across the baud rate for the UART, because that needs to be faster for the CrazyDude stuff. We'll set up password. I mean, 1234 is the default anyway. With the password, make sure you include the quotes because it doesn't like it. You get an error back if you don't. And then what we'll do is we'll change the name, probably to something like Taranis, something that we know what it is we're connecting. Could be R9, whatever you want. But yeah, I'll call this one Taranis. Again, this should be an uppercase. I've used underscores and dashes, and that seems fine. But if it doesn't come back with OK, then there's a problem. You need to pick a different name. So there we go. That's the settings for the CrazyDude Android stuff. What I'm going to do in a sec is change this to use the GTS or the U360 GTS master, because that's what I'm going to set this module up for. I already have the other module set up for the Android stuff. So I'm going to be, I've already set the name, that's fine, but I'll need to make sure that the baud rate is correct because I've just changed that. So that needs to be 9600 for the tracker. And then we also need to change the password, and we need to set it up as a master. So that's what the role equals 1 is, setting the device as a master device. If you set role equals 1 and try to hook it up to Android, it won't work. You need to leave it as slave for it to work with Android. And then what I'm trying to do here is actually enter a code which is spelt incorrectly. So when it goes in, you can see there's no OK. It does nothing. It doesn't know what it's doing. And sometimes different AT boards use the semicolon. So as you can see, I'm trying different things here, like the quotes. And what I'll work out in a second is I've actually spelt it wrong. It should be C mode. But yeah, fat fingers have typed it in wrong. So when I put that in the description, I need to make sure that I type it in correctly for you guys. But what I'm going to do is pull up a web page, which is really useful. Again, I'll put it in the description. Like in any of this stuff, I'll put in the description. And this page here is what really helped me. The guy in the Fixed Wing RC Rebels group posted the link to this, and that made everything make sense. So this will actually show you how to set it up with an Arduino. So you don't need to get the TTL board if you don't, but if you've got a spare Arduino, and it will show you how to do everything. But this list of AT commands here is pretty useful if you want to take things further, or if you get an error like that, you can check and see that I've made a stupid mistake and spelt something wrong, and then you can correct the spelling and it will, as if by magic, work. So there we go. Okay, now we're back on track. So that's everything working now. And what you want to do now is just disconnect, and then you can unplug the USB like that. So get back to this. We don't need this anymore. What I would do is, if you're setting it up as the slave or to go on your Arduino, I mean not your Arduino, your Android tablet, disconnect the USB and then disconnect this EN or key cable, and then plug it back into USB, and then you should see the device in your list on Bluetooth, just to make sure that everything works before we get on to the next step, because you can do it, but it's a pain in the ass. So right, what we're going to do now, I'll just switch my soldering iron on. We're going to remove these pins, and then we're going to set this up to work with the SmartPort. So I'm just going to get a few things set up and I'll be right back. Okay, so what we now have is the basic tools I'm going to use for doing this, plus a soldering iron. So we have solder for attaching the new cables. We have desoldering wick or desoldering wire to get these pins off, and flux to also get these pins off. For wiring it back up, we have a 10k ohm resistor, and we have a 2N7000 transistor. So the first step is to remove these pins, which I'm just going to fast forward through this because it's quite a boring process. But what we're basically going to do is use the desoldering wick to get rid of all this solder to try and assist us to get these pins out, and then we're going to get one out at a time. Don't just pull the whole lot out because you'll knacker the board. But yeah, this stuff's brilliant. Just cut the used ends off. Just dip it in the flux. And then what we're going to do is just put it on the joint. And then it sucks the solder out of the joint. As you can see now, if it will focus. You can see there's a gap around it already. So we're just going to carry on do that with the rest of the pins, and then we'll work the pins out. They actually look pretty clean. Otherwise, I'd get a small drill bit and clean them up. But they actually look pretty decent. Right, so the next thing we need to do is wire up our transistor and our resistor. Right, so there's a diagram for this on both the U36 or 360 GTS wiki, which I'm just going to try and find now. Well, I was actually quite wrong. The file is actually on the CrazyDude website. So what I thought I'd do is, rather than go to the web page, so I'll grab the image. This was a photo taken by Powell Spakowski. So I'm borrowing his image. So thanks, Powell. I'll link to the web page, and also Powell's Quad Me Up inverter website, because what we're basically doing is adding an inverter. So what you can see is we have a power in the ground, which will come from our SmartPort servo plug, and that goes to VCC and ground on the Bluetooth module. So there's nothing crazy going on there. That's straightforward wiring. So next up, we have the 2N7000 transistor or MOSFET, and then the blue wire is going to the middle pin on that transistor. It's hard to tell on this photo, but it doesn't go anywhere on the board. It just goes to that middle pin on the transistor, and that's our signal wire from SmartPort. So what we need to do is invert that. So this is why we're using the MOSFET. The top pin, in this case, with this orientation on the MOSFET, goes to ground. And then what we have is the bottom pin is going to be our the RX pad on the Bluetooth module. And what we need to do is add a power source to that as well, which needs to be it's supposed to be 3.3 volts. But what we're going to do is add a 10k ohm resistor in line to reduce that voltage even further. So if you look on the Bluetooth module, it's actually it's two boards in one. You've got a main board which has got the components on, which I guess could be like power regulators, that sort of stuff. And then you have the green board, which is the actual Bluetooth system itself. And then the second pin in from the bottom right is a 3.3 volt power source coming from the board to power the Bluetooth module. So we're going to steal some power from that, and what we need to do is join that to the pin on the MOSFET that goes into the RX pin. It sounds a bit complicated, but when we actually get round to building it, it's really simple, so I'll show you everything there. So our transistor goes this way round. Just spread out the legs slightly. And I'm going to bend the two outer legs down. Sorry about the focus. And then these, so one leg, if a flat of the MOSFET is facing try and get this done. There we go. So the flat part of the MOSFET is actually facing the Bluetooth. This first leg here, that needs to go into the RX, and that should be it there. So you'll see that leg goes in the RX, that leg goes in the ground, and it's the flat part facing the Bluetooth module. So we can just push that in, bend the legs about to get it flat, and that's it. So just bend those out slightly to make it easier, and then we'll just solder that up. All right, so there we go. We've got our RX and our ground wired up. So I'll just snip those off. Right, so to do this part, we need to get rid of some of this shielding here, or this heat shrink. So what I'm going to probably try and do is just try and cut a little piece away. Oh, sorry. So because looking at the diagram, we want to go on this second pad in. So I'm just going to cut as little heat shrink away as I can, just to keep the rest of it protected, so we don't risk shorts or anything like that. So I'm going to do that off camera just because it'd be a bit of a pain. All right, so there we go. We've exposed that leg in that tiny bit of heat shrink cutaway. So now what we'll do is we'll solder on one leg of that resistor to that second pad in. Again, with resistors, it doesn't matter which way around they go. They're unidirectional. So we'll get a bit of solder on that to prep it. And this is going to be quite fiddly. So we'll see how we go. Trying to get it on camera while I do it. There we go. It's on there. So now what we do is we bend that round. And then all we need to do is get that onto that leg there. Oh, sorry. Get the wire onto that leg of the MOSFET that goes through the RX. So we just need to solder those together. So there you go. And then we'll just cut that leg of the resistor short. So that's that part done. So the next part is a hell of a lot simpler than that. What we need to do now is get the 3 wires that are going to come from our SmartPort plug, and they're going to be simple. We're going to have one for VCC, which is going to be the power in, one for ground, and then the TX from the SmartPort is actually quite convenient. It lines up with TX. It actually goes on that leg. As again, don't wire it to the Bluetooth module itself. It wires onto that here, which obviously will cut short. So I'm going to cut that short now. and grab some wire. I mean, this wire is 26 American wire gauge, or AWG. 28 would probably be slightly better, especially if you want to do the double plug thing. Where this is going in the tracker, I'll probably just do a single plug straight to SmartPort for this one. And I sod it. Right. So I'm just going to use this one that I've already wired up to get the length of cable. Apologies if half of this is off camera. So that's the length of wire I'm using, which is 14 centimeters. Again, it doesn't need to be exact, it's just a bit of wire. Whatever reaches the socket on your Taranis or... So now let's work out the length of these wires. It's going to be about there. So that makes one cable just over 5 centimeters. So I'll do it where you can see it. So as you can see, it's just over 5 centimeters, but so about 52 mil roughly. And then this is the other one which comes from the Bluetooth module, and that is about 89, 90 mil. So that's the length of our our wires. One's going from Bluetooth to the standard SmartPort, and the other one's going in the JR bay. I mean, again, if you're using this with something like a QX, I think the QX7 has it, but there's transmitters now which just have a standard SmartPort in the bottom, so you don't have any of this weird wiring stuff. It's just if you're using the JR bay, which if you don't know the JR bay, sorry it's out of focus, but this here is the JR bay. So this is the R9 module, and you can see up here these 3 pins here. This is the SmartPort. So you have at the bottom you have the ground, in the middle you have the power, and at the top you have the signal. So that's a normal servo type wiring. But if you take this out, what you have inside, you can see these 5 pins, if I can get it. And these are, this is still SmartPort, by the way, but it's wired different. So the bottom is the signal, the middle is the ground, and the top one here is the power. And that's the confusing one. If the power and the ground were the other way around, then we'd only need one. All right, so let's get that back in, and we'll carry on. Right, so what we'll do first is wire up the back, so it's easier. Sorry, I need to turn it this way around. You can sort of see that. Right, so the ground has already got a bit of solder on it because we've used that for the resistor, so just freshen up the soldering iron. And then this will go straight onto this here. Is that done? Now this one we could put through the hole, or we could just solder it up. See if it'll go through. Be a bit neater. Maybe I'll make it a bit longer. Or we just fill it in. I know people that solder well will hate this, but so there we go. That's sort of in the hole. Right, so that is our ground and our power. So all we have left to do is the SmartPort, which again it's going on this little spike here. So because this is a bit of a pain, you might not be able to see it so well, but I need to see it a bit more than you do. I'll show it when it's done. So we'll tin up the leg. This is already tinned. I know it's not the best way to do these joints, but there we go. So the soldering is now done. I can get that out of the way. And then what I'll do is I'll get a bit of heat shrink onto that leg. Which should give it a little bit more strength and also protect it. So we'll heat shrink that on. There we go. All right, so that's shrunk on. And we'll get a bit for the rest of the module. And it only really needs to go over the work that we've just done because there's heat shrink on it already. So I've got this heat shrink here. It's a little bit too small, but this was a good tip that I picked up. Actually, I have to give credit where credit's due. It's Mr.D. So just stretch it slightly with some needle nose pliers and it will go over the top and it will shrink down nice and tight as well. So let's get the wires through. And as I say, I just want this to go over the cable, the wires we've just done. It might be easier from the other end. Get a bit more of a stretch. No matter how many different sizes of heat shrink you buy, you never have the right size. It's just one of those things. Alright, so there we go. That's going. So I don't know if it matters or not, probably not, but I just want to get it clear of the antenna. And then we'll give that another blast. Right, so there is that part, or that end of the module is now complete. So I'm trying to get some images for you. You can see, I think with the black heat shrink on, you can clearly see that that SmartPort lead signal goes straight to that middle pin. Resistor and that leg goes into the RX, and then that leg goes straight to the ground. So that's how that end is wired up. The rest of it is servo plugged, so it's nice and easy. Okay, so now all we need to wire up is our servo plugs. That is what we use to get into the SmartPort plug and the JR bay. So let's get this prepared. These little servo kits and these JST crimps and stuff I got from Hobby King. They're pretty cheap there. And also these things, which are brilliant. Right, so first one we're going to make is going to have 2 watts of wires in it. So I strip these down a little bit longer. Just because getting, I'd say with maybe 26 AWG you might, sorry, with 28 AWG you might be alright, but it's tight getting these into a servo plug. And this is all nice silicon cable. This is all Taranis stuff. Again, from Hobby King. Which at the moment, because we're in lockdown, they're closed. So I've ordered some more from Amazon, which is 28 AWG. We'll see how that stacks up when that turns up. But yeah, the Taranis stuff's pretty decent. Alright, so I'm going to twist these cables together. But before I do that, I'm going to set up the crimps because it's just easier. So that goes in the pliers. Alright, that's ready. Alright, so that's our first lot done. So what we can do is whack the red in, because that goes in the middle anyway. That's the best thing about this plug. It's a shame that the inside of the JR bay doesn't match this, because you know, if you put these on backwards, you're not going to blow anything up because the power is always in the middle. Alright, and what I found is you have to get in there and push that up so that you can lock it off. Once it's in, it's in. It's quite tight, but it's not going to come out. Alright, so the next one on this side here is the signal. So again, push it in as far as we can, and then just get that in there, try and get it on. I don't know if I can show you on here whether it'll focus or not. But just below where it locks in, there's a slight gap, and you can just get a knife in there and push it. It's obviously really not the safest thing to do, but it works. Sometimes it will just click in. Other times like that, you're not so lucky. We got it? Yes. And then ground. There we go. Sorry, you didn't see that, but there we go. That plug is done. So that's ready to go in our R9 module. That'll work a treat. But what we're going to add is the other plug on this side, which will go in our JR bay. Right, there we go. That's all the crimping done. Now we just need to wire up. As I said, this one is a different plug. So what we have is on the bottom in the JR bay, we have the blue. So that can go in there. Then in the middle, we have the ground. That's in there. And then at the top is the power. So there we go. That is our finished module. The only thing I will do is I'm going to add a little bit of heat shrink to this one and a bit of paper inside with JR on. I'm not going to do it now because honestly, I'm sure you all know how to heat shrink and write JR on a bit of paper, but it will end up looking like this one. So that's how to build them. So next we'll have a look at the Taranis. Right, Right, so here's our Taranis. On the back, we have SmartPort here on the R9. So I'll just plug that in with a signal to the top. If you're unsure, there's a little diagram down here where you can see the top one's got the wavy lines for the signal. So we'll stick that in there. It won't light up yet because it's not switched on, basically. So now what I'll do is I won't actually be able to show you the Bluetooth module, I don't think, with... let's see, you can just about see it there. So what I'll do, I'll switch that on. I need to change my clock battery. Right, so that's plugged on. We've selected my generic R9 iNav model, and just over here I have a mini AR wing all ready to go. It's not switched on yet, so if I go to the page, you'll see there's nothing in the telemetry. Right, can you just see there? I don't know if you can see it or not, but there we go. You got an LED flashing on the Bluetooth module. This is to say that it's ready to be paired. So what I'll do is I'll grab my Android tablet and turn on Bluetooth. And what it should do is scan for the devices. And then you see here we've got Taranis Bluetooth. I'll get out of the way of my ring light. Pin code is predictably 1234. And there we go, we're paired. So that's still blinking, but it is paired. So now what we want to do is go to Telemetry Viewer, which the link for that is on the CrazyDude's GitHub and all that. So I'll again link to that. And then you just click connect and then choose your Bluetooth device. So it's connected. We've got nothing at the moment because there's nothing plugged on, but if I switch the plane on, then we should start getting stuff through. So we've got RSSI now. We've got voltage per cell, and we've got TMP2, which is basically satellites. So because that's not getting any, what do I stick that? One sec. Stick it closer to the window, we might get some satellites or something like that. But yeah, you can see it all matches up. So we've got 3.6 volts per cell, which is 3.6 volts per cell is A4 is 14.9. It's a 4-cell pack. We've got no satellites yet, so we'll see if we get some satellites. But I'm indoors, so maybe not. It's not been switched on for a while, so it might take a while. But yeah, as you can see the telemetry is working because we have the battery voltage, we have the amps, which is 0 because it's not actually doing anything. I don't know. We have satellites. There we go. So yeah, we've got 6 satellites, which you can see the last number on TMP2 is how many satellite fixes you've got. So we have 6. That's come up with 6 on there. I've got really crap Wi-Fi in this room, which is why it's not drawn a map. But you can see it's working. So there you go. That's how you set up the Bluetooth modules for your Taranis. If I would say if you've got any questions, leave them in the comments. But unless it's for this specific module, I might not be the best person to speak to. As I say, I had lots of issues with that, getting it set up in the first place. But knowing the module and the commands and that one trick of holding the button down while you powered it on, that was the thing that broke everything's back. Is once that was sorted out, it worked absolutely fine. So yeah, if you've got any questions, I'll try and answer them. But in all honesty, the best thing to do first may be to look at the back of the unit, see if it's got a specific number on, and Google that, because it may be that there's a slightly different sequence for when you power it on, or there's slightly different commands for AT commands. But no, it's working really well. As you can see, it's up to 12 satellites now that is matched up to what's on the Taranis. I know it's like there to there, but it's still working absolutely fine. If you found this video useful, a like would be great. If you want to see more of these types of videos, thumbs up, subscribe, and the bell icon would be awesome too. Thank you for watching, and I hope you did find it useful. All right, thanks. Goodbye.